Okay, hello, welcome to the channel. My name is Victor, and I'm going to be your anchor for this series. Okay, so this is lesson 3 of the CompTIA Security Plus certification. So this is the updated 701 exam. We've looked at Module 1, we've looked at Module 2. So this is 3, and we're going to be looking at cryptographic solutions. So here, the objective of the curriculum is to make sure that you're able to explain what kind of solutions that might be feasible for whichever kind of circumstance. So you want to be able to differentiate, you want to be able to compare the different cryptographic algorithms. So an algorithm is just a formula through which you can use to create ciphertext for a particular type of plain text. Now, you have different types. They can be either asymmetric, they can be symmetric. So we're going to look at that in clear details. Now, I also want to explain the importance of public key infrastructure, that is PKI, and digital certificates. So there's going to be like an infrastructure to be able to help in creating, distributing, managing, of course, both date of inception of the cryptographic key and also expiry, because for most types of digital certificates, once you have them, they will have a lapse, a time when you set them up and when they are expiring. So what is going to help us do all of those management? So that's where the PKIs come in. They also want to explain the importance of using appropriate cryptographic solutions for encryption and key exchange. So whether you're doing disk encryption, whether you are doing digital files, whether you are doing maybe folder, whether you are doing any kind of thing you want to encrypt. So what is going to be the best type of solution you need for it? So if you're preparing for your CompTIA Security Plus exam, so this is a very important module. So for your exams, I'm going to be pointing out most of the important things you want to look out for your exams. So this is 3A, and in 3A, we're going to be looking at cryptographic algorithms. Now, anytime you hear the word, for this exam summary preparation, anytime you hear the word encryption and decryption, we're talking about encoding and decoding. So take, for instance, you have, my name is Victor. So my name is Victor is plain text, right? So plain text is the unencoded message. Then if we encrypt this particular message and we have something like ABZ2535A2253232, AB525, kind of long kind of text that is encoded that represents my name is Victor, that becomes the ciphertext. So ciphertext and plain text. So plain text is the unencoded, right? A message that you've not encoded, just in its plain natural format. Then ciphertext is the coded message. So cipher is a means of change or algorithm. So you have some concepts here. Cryptanalysis is the act of cracking a cryptographic system. So if you have a system that is being encrypted, so that act of unlocking that, you call it a cryptanalysis. So here we're going to be using some scenarios using Alice and Bob. They're also going to consider hashing algorithms. So when you hash, you're trying to make sure that your plain text isn't visible. We're going to do that for the students we have in the study groups. So for CompTIA Plus, we have some study groups. We're going to be looking at hashing. We're going to be looking at sorting. We're going to be looking at peppering. We're going to be looking at different applications, especially on database systems, on servers, on websites. So some of these examples will help you get to understand these things in real terms. Then we also have encryption ciphers. So like I said earlier on, it can either be plain text, or rather it can either be symmetric or it can be asymmetric. So we're going to see the differences. Now, encryption uses, so when we want to explain what encryption is, so it uses a reversible process. And that process is like an algorithm. So if you have a formula or an algorithm that is 25A25, maybe an item, maybe a variable, then you have some other items. If you factor in that those variables into the formula, you now get something. So you have a plain text, you have an algorithm, you have a ciphertext. So the algorithm is what helps in reversing or changing this particular plain text into the ciphertext. So you say encryption uses a reversible process based on the key that is only known by the authorized person. And at times substitution is possible. Like the example I gave, you have a formula that if you want to get a ciphertext, you just substitute. And at times you transpose. So transpose is when you like turn either upside down, down ways, whichever way. So process should be too complex to unravel without the key. So encryption should be something that if you just look at it, you're able to demystify and say, okay, with this, if I put this to this, I'm going to get the end answer. So it's always a little bit complex. Now, one thing you should know about symmetric encryption is that the same key, it's used for both encryption and decryption. It's just like you having Alice trying to communicate with Bob. So you have Alice here, Alice and Bob share a symmetric key. So if to enter into a door, you use same key to open this way and same key to come in from the other end, that's simply symmetric encryption. So it's fast, it's suitable if you want to do some kind of bulk encryption of large amount of data, because if you have to do asymmetric, it's going to be slower. Then it's also, of course, it's going to be slower. Then it's going to take more time, right? So some of the features for symmetric encryption is that it's the same key is used for encryption and decryption. It's also fast. You have problem at times storing and distribution keys securely. Confidentiality only, right? So sender and recipient knows the same key. Okay, so let's look at this concept of key length. Now, if your key is not too long, so it makes it less secured. So key ensures ciphertext remains protected even when the operation of the algorithm is known. So even if you know the formula, if you know the encryption methodology, but because there's a key involved, it's going to be difficult for you to be able to know what the answer is, right? So key is just like a password, kind of. So range of key values is the key space. So how long? Longer key bits length means a larger key space. So this is going to help us prevent brute force. So take, for instance, in your exam, you have a question that have to do with which of these algorithms is going to take a longer time to break. So you're looking at key length. So the key length is longer, so it's going to be more better. So the longer, the better. And of course, advanced encryption standard uses 256 bit key. Okay, don't forget that the longer the key, the more power, the more memory, the more resources that's going to be used to like unlock. It's just like you having a very large formula, and all the formulas have a lot of variables, a lot of computation. So the longer, the slower is going to be in terms of unraveling it, but the more secured. So you don't use that when you're trying to do some very simple encryption kind of stuff. You use symmetric key. Okay, let's look at asymmetric encryption. So here you're going to have a public and you have a private key. So if the public key encrypts, only the private key can decrypt. So you don't open with the same key. So private key cannot be derived from the public key. Private key must be kept secret. I think for the students in the study group, so if you're trying to prepare for the CompTIA Security Plus, you can contact us. We're an accredited CompTIA partner. So you could do Security Plus with us. You could do Pen Test. You could do A Plus, Network Plus. You could also do Cloud and Project. So if you're in the study group, we're going to consider generating from a PKI something like an SSL certificate. That's where you're going to see in practical terms what you call the private key, certificate authority, a key, then you have your public key. Okay, so this can be used for small amount of authentication data, right? So if you use it for something very large, it's going to take quite a lot of time. Then different ciphers have different recommended key lengths. So you have RSA, it's 2048. They have elliptic curve cryptography. So you have 256 bits or better. Now let's look at hashing. So hashing is a one-way plaintext, is a one-way kind of function. So you call it a function. So this plaintext cannot be recovered from the digest, and it also helps to avoid collision, so that we don't have two plaintexts returning the same digest. Now, the two popular ones are SHA and MD5. I used to have MD4, but not really in use. So SHA is 256 or better. That's the length, that's the bits. Then you have message address is 126. So if you are asked questions now in your exam, for instance, which of these two is going to provide a little bit more security for us? So it's going to be SHA. That's why you see most sites, either digital certificates or TLS or SSL certificates or fold-out certificates, most of them use SHA. So in some instances, MD4 rarely is used. That's why you see in older systems, they're going to use the more older algorithms. So MD5 and SHA is a little bit more recent. You also have SHA up to 512, right? Let's look at digital signatures. So digital signatures is going to help us use public key cryptography with hashing, right? So you should be able to differentiate between sorry, just a second. Okay, I was looking for something. So for digital certificates, understand that we are not just looking at confidentiality in the case of symmetric encryption. We're looking at also integrity, authenticity, and non-repudiation. Don't forget that in cybersecurity, our goal is actually ensure those 5 elements of information security is being implemented. So we want to ensure confidentiality. So if we want to ensure confidentiality, what do? We encrypt. We conceal the data so that the person that is not supposed to see that information doesn't see it. So we're also trying to say that, what about if somebody sees it? So we can go a step further by doing hashing, or even if somebody sees the algorithm, can we add something to it? Can we add a function, right? That's going to help us provide integrity. So in integrity here, we're trying to say, okay, we can't change, we can't pilfer, we cannot adapt the particular data. Then in authentication, we're trying to say we want to be double sure that the person said he is who he is, because somebody else can have that message, can have that data, claim it to be the other person. So that's one of the reasons why you have what's it called, digital signatures. And of course, non-repudiation. You don't want somebody to deny that he or she have seen a particular message. So that's where login is. That's where you have non-repudiation. So let's review some of the things we've talked about. So the curriculum is very light on cryptography. So what you just need to do for your exam, be able to differentiate the different types of encryption, which is symmetric and asymmetric, understand their features, then understand the different algorithms that are under the different types of cryptography, right? For the lab, for students in the group or later on in the channel, you can also check the channel for the Cisco CyberOps certification. I did a very detailed encryption kind of explanation. Now, I could also provide the PDF for the Cisco CyberOps encryption module. It's more detailed, it's very detailed. This material is for students that are preparing for the exams, that have done 1 or 2 readings, and they're trying to summarize their learnings and make sure that they understand all of the content for the exam. We expect to the curriculum. For this one, for students in the internship or students in the study group, we are going to be doing some basic folder encryption or storage encryption. So you could encrypt your hard disks. You can encrypt maybe a folder in a flash drive. You can also encrypt a flash drive. So we're going to be working on that lab. So let's look at public key infrastructure. So we're trying to say that if we are to do encryption, if we are to do hashing, if we are to do all of these things, there need to be some kind of systems to help us implement this. So that's where the PKI comes in. So the PKI, what they do is that they help us provide identity or prove identity of a particular user or computer. So how are we sure that you have the person? How are you sure that you are accessing from a computer that meets the requirement for us to be able to transmit data to you? So then the certificate authority is going to be the repository for certificates. So you have things like GoDaddy, Komodo, Sectigo, you have Let's Encrypt. All of these are different certificate authorities. So you can explore that. Take, for instance, if you want to purchase a digital certificate, if you want to purchase SSL, if you want to purchase an encryption for either email, who is going to provide that for you? So that is who you call the third party. That's who you call the certificate authority. Then we have third party CA. So third party CA are also going to be guys that are going to also distribute CA. For the CA, and at times they are also CAs, and at times they can also be companies like Google, like Mozilla. All of these companies that are going to help us make sure that we uphold this. If you see, if you take an instance on your browser, let's say you're using Firefox or Google Chrome, these companies, they have browser systems and the rest, and your date is not correct, or your browser is not updated, you see there's a relationship between the third-party CA, the CA, and the PKI. So you can be told that, oh, this certificate is expired, or this certificate it's not correct, or this certificate, your date is not correct. Now you have entity that's established widespread trust in these policies and procedures for issuing certificates. So they work all hand in hand to make sure that you have a secured system. Like I said, we're going to be doing a demo for this. We're going to generate a CSR, like a signed request. We generate a signed request, then put it on a CA, then collect it, implement it on a server, then authenticate it. We're going to do some of these labs later on. So for an example of a digital certificate on your browser, if you go to, let me see if I can get out from this place. If you say Google, for instance, google.com, if you tap on this place and you click on this site is secured and click on this place, you're going to see something like this, right? So you see, this is the common name for the domain. You also have, see the certificate. So you see, you have 256 here. If I say google.com.ng, so the the hashing for this certificate, this particular certificate is 256. Let us check SSL checker and see some more details for the encryption used for the site. Let me check. So you're going to see something like, okay, this certificate resolves to 152. This is the server. Certificate should be trusted by all major web browsers. Now it's expiring 65 days. This is the name. This is the validity, right? So then this is the serial number. So this is the algorithm. The algorithm is SHA-256 with RSA encryption, right? So this is the hashing. This is the encryption. So you have an encryption, you encrypt, you now hash. Those two go hand in hand. Then the issuer is RW2. Let me see what RW2 means. Let's see, certificate authority. Certificate authority. Okay, so I think, let me see just a moment. Okay, you can check that and let me know in the comment section. So you have different certificate authorities for different certificates. Okay, the issuer is GTS root 1. So I don't know whether it's a Google. I think it might still be Google, maybe Google Trust Services or something. Google Trust Services, yes, correct. So this is Google Trust Services LLC. So it's a company owned by Google that is a certificate authority that is responsible for issuing certificates, right? So you have the chain. So you have a more detailed for this TLS certificate, times which you call SSL certificate. So this is the certificate and this is the public key. So this is a classical example of encryption and hashing at play, but a digital certificate, right? Current slide. Okay, so this is the example I just gave to you now. Okay, so you also have, if you go back and check of root of trust, so you have the root certificate, whether it is self-signed, whether it is, so users must trust in the CTA security procedure. That's why you see some self-issued certificates at times. They don't work in most browsers. So it's good to always use certificates from trusted sources. Then you also have things like the certificate fields to give you all the details, then the different field names, right? Okay, so you have certificate signing request. So this is what you do most of the times if you want to initiate a certificate. If you purchase certificates, digital certificates from what's it called, from certificate authorities, that's the process. So to practicalize this, I'm going to do this in one of the hands-on so that you understand what it looks like. It's a very straightforward process. You first generate a certificate signing request from your platform, and you take it to your certificate authority. It's authenticated for verification. Then once it confirms your identity, you take it back. Then, of course, you implement and you install. So this is what the process looks like. You just generate some key pairs. You take it to your certificate authority. It confirms your identity. Then it signs and issues you a certificate. So I'm going to do this hands-on. So don't forget to stay tuned as we move on in this series. Okay, so these are some of the attributes. I've explained this. You see that some certificates that might be protecting or securing several field names and domains. You have the examples here. And at times it might just be just one domain, or you can have a leading domain. I think we have that. We have something. I saw something like lead certificate. Okay, not okay, leaf certificate. So you might have it operating at the fully qualified domain name. That's like something.com, something.org, not something.something.com. No, that's not a fully qualified domain name, right? So if you say victor.com, that's a fully qualified domain name. If you say blog.victor.com, that's a subdomain name, not a fully qualified domain name. Then you also have some certificates that can actually protect subdomain names. You call those ones wildcard certificate, wildcard. That is WILDCARD, wildcard. Okay, so there's what to call certificate revocation. So this happens once it's expired, or you have issues, or the browser is old, or there's several reasons why you might have revocation. Then you have a revocation list of revoked and suspended certificates, browser CRL check-in. So that's why I say the browser is also very important, and browser owners. So normally they will check these domain names, right? And see if there's still validity before it allows them to run through. Okay, so in key management, there's what we call key life cycle. So you have to generate key, and then there's storage. So you have generation, storage, revocation, expiry, and renewal. So these certificates, they do expire, just like the one we saw for google.com with NG. Then you have decentralized key management. So each host or user stores its own private key. Like we're going to see in the lab. So my own key for my digital certificate is going to be unique to me. Somebody else does not store it. Even the PKI, the C8 doesn't store it. So that's what I'm going to use to authenticate and verify my digital assets. Then also you have key management system. Keys are generated and stored in a centralized server, and there is interoperability, right? So that for different browsers, for different systems, it still works. Okay, so this is so anytime you hear the word entropy, so we're trying to talk about randomness, right? It's going to tell with respect to ease of breaking the system. Then you also have TPM, a trusted platform module. So you have this encryption at times in some hardwares. You also have it in some virtual appliances. Then at times you have it in some devices that you want to reduce tamper. Okay, so we also have key escrow. So keys can also be backed up to protect against data loss. And when we access to the backup keys can impersonate the true key. Then you have M of N control. So key recovery processes can be protected by, I think this has to do with the maximum number of agents and the number of agents in control. Then you have split key into multiple parts held by different key recovery agents. So all of this is to ensure that you have a secured system, because if you have a secured system, you have better encryption. Because even in encryption, if not done properly well, these are some of the loopholes that you might have. Okay, let's do some reviews. We talked about certificate authorities, digital certificates, root of trust, certificate signing request. We're going to do a lab on these. A subject name attribute, certificate revocation. So it can happen, it can be revoked, it can be because of several reasons. You also have key management, crypto processors, and secure enclaves, where you want to protect hardwares. Then, of course, you have key escrow. So let's look at cryptographic solutions. So what are the kind of solutions that we might have for our browsers, for our cloud apps, for our mobile apps, for our sign-in systems, for our site security, for our folders, for our files? We have quite a lot of different solutions that might happen or that we might implement. Because here we're trying to protect data, and data is going to be at different instances. So it can be data at rest. You just have a file that is within your system, that's data at rest. Or it can be at transit, to transferring data from your file or from your system to your pen drive or your hard drive, or you're transferring data, you are filling a form on a website, you are transferring data from your browser to the database or the server of the website, or you're trying to make a purchase and you entered your card details, and your card, that data is being authenticated, so it's going to transfer from your browser to the authentication server. So that's data in transit. Or data in use, data you're currently in use, or let's say you have Google Drive, and you have a document on Google Drive, and you're filling the form, not filling the form, and you are editing a document on Google Drive. That's data in use, right? Or you have a file within your system that is shared on a network and you're actively using it. So these different states, there are different types of encryption we should be looking at. So you also have bulk encryption, where you want to use private asymmetric, which at times can be inefficient for working on large amounts of data. So this is one of the downsides if you use asymmetric key, because you're going to have a public key and a private key. So it then means that what you're going to use to like encrypt is not what you're going to use to decrypt. So it's going to take a longer time because your bit is going to also be longer. So it's going to be very inefficient. It's going to be slower. So for bulk efficiency, you look at symmetric key. Okay. So disk and file encryption. So this is very, very, very common. Your Excel document on Microsoft Word, you could encrypt it, you could password it. Your file, you could use any file or folder encryption software. Just Google that. You're going to see so many of them. You could use that to do either data at rest or your disk or encryption. And at times you can do encryption also for your system. The operating system at times provides that facility. If you say encryption, right, you see manage bit lockout. So most operating system still provides that for you. So in terms of data encryption, let's look at different type of data. So we have structured data. For some of us that are database administrators, for some of us that are developers or that can program, you understand some of these concepts very well, right? So if you have a database is just like a sheet that have rows and columns. Now, the thing is, when somebody fills a form on a website and he submits, the data goes to the database. The question is, if it's a password that is entering, should it be stored in the database that same way? So that's where encryption comes in. So either we're using a database management system like MySQL, Oracle, or MongoDB, MySQL Server, whatever kind of database management system we are using, we want to make sure that there's encryption. So this is the responsibility of the programmer to make sure that he's encrypting very sensitive data that should be stored on the database. And of course, you use SQL, that's SQL, or structured query language, to like perform CRUD. That is create, read, update, delete. So if you are going to save to the database, you do what? You use CRUD operations, right? If you want to retrieve data, you want to read database. If you want to delete something from the database. So in trying to do all of those back and forth, there must be security in action. So you can have database level encryption. You can have record level. That means you are protecting the entire database. And also, you're also protecting the items within the cells of the database. So if you enforce this fine-grained access control to support compliance requirements for privacy and security, you'll be providing a better system for security. Okay, what else here? So these are some illustrations to help you understand these concepts. Then salting, peppering, and the rest. Now, salting is just like when you add salt to your food, right? So aside hashing, you can still add something to your data before you encrypt. So this goes to like provide more security, right? If your food tastes normal and you what was it called? And you add salt to it, what happens? It gives it a little change, right? So salting is going to add a random value to each password when hashing it for storage. So this helps us to have a, what was it called? Helps us have a more secure system. So I want to give you a task now. You can reply in the comment section. Try to differentiate between hashing, salting, peppering. So hashing, salting, peppering. Do that with an example. I think that will really help you going forward in your preparation for exams. For blockchains, we're trying to look at ledgers, we're trying to look at peer-to-peer transactions, we're trying to look at, and in all of these, blockchain have different application in healthcare, in finance, in digital certificates or digital asset protection. Now, we want to make sure that, one, there's transparency. We want to make sure that there is security. We want to make sure that transactions cannot be actually deleted or reversed. These are some of the characteristics of blockchain, and it has application in online voting system, like I said, in healthcare, in identity management system, and the rest. Obfuscation. So anytime you hear the word obfuscation, think about integrity, not integrity, sorry. Think about confidentiality. Anytime you hear the word obfuscation, think about you trying to mark something, trying to make something not clear, something not hidden, something not clear. You want to conceal. And some of the application of obfuscation is steganography, data masking, tokenization, and de-identification. So these are the different concepts you can use to actually make sure that data is not as clear as we receive it, either in storing it, either in transferring the data, either in using the data. We want to make sure that there's some kind of obscurity. And in steganography, you have application in the different kind of content. Whether it is video, you can do video steganography. Whether it's text, you can do text steganography. Whether it's image, you can do image steganography. In image steganography, for instance, is you saying you have an image, you can embed a text file. A very quick example is a quick stego. You can Google that and check that, download it, and you can practice with it. It gives you a clear example of how to do steganography or how to do obfuscation. So at times you can use that to transfer files, to maybe show people file, or to transfer file, or maybe to deliver a malware. You also have data masking when you are redacting information from fields. Instead of saying, my name is Victor, so the Victor, you can obfuscate, you can data mask the inside content. So you just say V and R. So the question is fill in the blank space. This is applied at times if you are told to reset a password and an OTP is sent to a phone number. Now, we're trying to make sure that we encrypt. This is cryptography, but this is a more lesser form of cryptography where you're trying to do obfuscation. You're trying to say, if I reveal this confidentiality now, if I reveal the data, the information that this particular phone number is this phone number, somebody else can try to hijack that phone number and do the reset. But if I conceal the phone number and I tell you to enter the phone number, I just give a clue, I just obfuscate, I just data max, I just redact, I reduce, I remove some of the information from the fields. It makes the system more secured. Imagine you having a database of, let's say, cybersecurity analysts in a country. Maybe you have 10,000 of them. You have the list online. And in the emails, you have the full emails on that web page. That is not security. It's going to make a whole lot of sense. I think we implemented this kind of thing on a website we're building for an international association, where we had to obfuscate some of the data on the public page of some part of the website. So that's a way to do obfuscation. You also have tokenization, where you want to substitute data with token, and also you have the identification. So all of these are examples of encryption. So for this review, we talked about encryption supporting confidentiality. We talked about disk and file encryption. We said we want to do this as a hands-on lab. We talked about database encryption, that for database administrators, they must make sure that they are not just saving data on the database. That's what you get when people use default templates to build websites, softwares, applications, when people don't go ahead and implement security on a system, when people don't go ahead to make sure that they encrypt what is saved on the database. That means if somebody gets hold of the database, All the passwords and the usernames and the emails of all the users on the application is going to be clear, right? And other things we looked at. So for the lab, we're going to also do hashing and sorting. Don't forget the task and assignment are dropped within the content. So I want to see that in the comment section. Thank you very much, and I'm going to see you in session 4.